Arkadaşlar, now in this video, I will be talking about continuous random variables, okay? This time, my random variable is continuous, so it can take any real value. It doesn't have to be discrete. And then we will be talking about the probabilities and such properties of continuous random variables. If you remember, in discrete random variables, we had PMFs like that, right? 0, 1, 2, and so on. This was like K, and we were talking about probability of K obtaining any value like that, right? So this time, we won't have any PMFs, but this time we will have PDFs, okay? Probability density function. So PDF is something that you will hear very often. We may write it like that, PDF or PDF, probability density function. For continuous random variables, we have PDFs, okay? For discrete random variables, we have PMF, probability mass function. So in discrete random variables, we were always talking about summations, summation of probabilities in order to find the CDF of a random variable. We were using the formulations like that. If you remember, P X like XK, and then we were finding like this one is X is less than a value, and then this was given as the CDF function, right? So this time we will be talking about, instead of summation, we will be talking about integration like that, okay? All the values will include some kind of integration. Another thing that we discussed previously was like all the probabilities, when I add them, it should be greater, it should be equal to 1 for a discrete random variable. In continuous time, it's a little bit different, okay? So let's focus on the discrete time part right now. Let me clear these parts out and then focus on the continuous random variables here, okay? So in terms of discrete random variables, we were talking about sigma. Now we are talking about integration. Okay. Arkadaşlar, for example, if I roll a die, there are 6 chances, and obtaining 1 would give me the probability 1/6. If I flip a coin, okay, for a die, this was the case. For flipping a coin, there were 2 chances, and the probability of obtaining 1 of them was equal to 1/2, right? So how about, for example, in a certain range of something like that. For example, I have this range between 0 and 1. And what's the probability of obtaining 0.5, exactly 0.5? In continuous random variables, we don't do that, arkadaşlar. This is a very critical information, okay? In terms of probabilities, we don't say what's the probability of obtaining exactly 0.0, 0.5 or 0.9 or something like that, okay? We usually talk about the probability of a certain interval, okay? So, because between 0 and 1, there are infinitely many real numbers, and obtaining this exact value would be impossible, right? So instead of this, we say, this is my interval, and I would like to find the probability of an interval. Like, for example, this is 0.4, and let's say this is 0.6, 0.7. What's the probability of a value, of a random value that is generated between 0 and 1, that is coming between these two values, okay? So what's the question? I would like my random variable, random number, between 0.7 and 0.9, 0.7. How do we find this? if we divide this interval into 10 subintervals, and now obtaining a random number in this interval would be equal to 1/10, right? Because my general number is like that. So I will generate numbers here, 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 uniformly. This is called like uniformly, okay? I'm generating random numbers uniformly. So in this case, the numbers that are generated in this interval would be like the probability of that interval would be 1/10. If I would say like I want my random, what's the probability of obtaining a random number between 0.2 and 0.7, then I would say out of like 0.7 minus 0.2 divided by 1 minus 0, right? 1 minus 0, 0.7, 0.2, which is equal to 0.5/1, which is equal to 1/2. So 50% of the time, if I randomly generate a number, but I have to generate uniformly distributed numbers, then I would have half of the time, or 50%, with a 50% chance that that number will come from that interval. Okay, let me remind again, there is no probability of 0.5 in discrete time. Instead, we talk about probability of an interval. Okay, that's why we always use integration. We always use those kind of things. In the probability density function, arkadaşlar, in continuous time case, this is my PDF, okay? And this is my CDF. For PDF, I use small letters. For CDF, I use capital letters, okay? So can you see this trick here? The PDF, the integration under the whole space is going to be equal to 1, okay? So this is how I understand that this is a CDF, and then you would really understand that like f of x is like my PDF, and the integration, for example, this is my PDF, and then the area under my f of x function should be equal to 1, okay? Now, I'm not adding up all probabilities as I have done in the discrete case. Now, I will have the random variables PDF, and then find the area under that PDF and find out the area under that PDF should be equal to 1, okay? So for example, I have this PDF, okay? This is like 0 and 1. Now, what is this value here? It should be 1 also, right? So the area under this is equal to 1 times 1. So this is the PDF of a certain uniformly distributed random variable. So I hope you get the main idea, arkadaşlar. For the CDF, we add up all the probabilities, and then for the integration of, for example, here I have my PDF, and how do I find the CDF function as I have shown here? Now the probability between -infinity to x, this value is going to be here, right? The area here is going to be my function for x. If I increase x like that, the area will increase. If I increase x like that, the area will increase. So the CDF for such a PDF will be like this. Initially, it is 0. Before 0, it is always 0. And after 0, it starts increasing because the area under this curve becomes zero, becomes increasing as we go until 1. What happens when we reach 1? It becomes 1 otherwise, okay? So after 1, it becomes 1, okay? So let me explain this once more here, and I will draw it here. Arkadaşlar, for example, if I have such a PDF function, okay, this is my x, it is between 0 and 1, and this is 1 because the area here should be equal to 1, okay? This is why, because our PDF, the area under the PDF is equal to 1, just as we have done the probabilities, additional probability or summation of probabilities is equal to 1. Now we don't say summation of probabilities, but the area under the PDF is always equal to 1, okay? So secondly, if I'm talking about the CDF function, f of x u du will be equal to fxx, okay? This is the CDF function. This is the PDF function, okay? I can write PDF or CDF like that, okay? You may find this in different books like that. So how do I find f of x, like CDF? Then I should take the integral from 0 to x, like that. Okay, what's the area under this curve? It's x. And if I increase x, still the area under this function is always x. And if I increase x, the CDF value will also increase. But up to where? Up to the value 1. Okay, because the area under the curve is always 1. And after that, it will be always equal to 1. Okay, so what did we do? Again, CDF is a continuous function. This is continuous function, and CDF is also a continuous function. Okay, so this part is critical, arkadaşlar. I hope you understand what's going on. For example, if we want to find out the probability of any number between A and B, it will be equal to the area under my curve, PDF curve, which is like between A and B, okay? So then this area here will be my probability. Probability of a random number between A and B should be equal to B minus A times 1, right? Because this is 1. So if you increase A and B, the probability of that number coming or obtaining is going to be higher and higher. Okay, let's move on to one exercise question and then finish the discussion over here. And I will let you solve different questions from the book and from MyLab system. Now our example is like this, arkadaşlar. I'm giving f of x being equal to, this is PDF. And PDF is given like that. There is one c, which is unknown. C times e to the power minus x for x greater than or equal to 0. So if I want to plot the PDF of that function, it should be something like that, right? So this is x, this is fxx, and this is c. Because when x is 0, c times x 0 is equal to c times e to the power 0, which is c times 1, which is equal to c. Okay, this is given, and the question asks, what is c here? Okay, how do we find c? What do we know? We know that the area, okay, the area here should be less than, should be equal to 1, right? So the area under this curve which is between 0 and infinity, should be equal to 1. And then this is the basic thing that I should use. And I'm going to come and use this property, c times e to the power minus x dx from 0 to infinity is my total probability, which is equal to 1. Okay, so I hope you understand this part. We put this in our integration. The area here is going to be between 0 and infinity. And I'm trying to find out that this area under this curve is always equal to 1. So how do I proceed? What's the integral of e to the power minus x? It is like c times minus e to the power x, okay, from 0 to infinity should be equal to 1. So if I put infinity here, c minus c times e to the power minus infinity minus c times e to the power 0 is equal to 1. Okay, I first put infinity here, minus I put 0 here instead of x. What is this e to the power minus infinity? It is e to the power 1 over e to the power infinity, which is like 1 over infinity, which is equal to 0. So this is 0. 0 times c is equal to 0. Okay, this is 0. How about this part? This is 1. This is c plus c. This is c, right? So 1 is equal to 0 plus c. That means c is equal to 1. And my probability is going to be equal to, probability density function is equal to minus c and 0 for x greater than or equal to 0 and 0 here. Okay, so my c is going to be 1, and I will continue with that. So what is the next question? I should find the CDF of my function. Okay, what was the CDF formulation arkadaşlar? I should take the integral. So I should find this. I should find the integral here, and then e to the power minus u du. Okay, and then again, I will come minus e to the power minus u from minus infinity to x, which is equal to minus e to the power minus x minus e to the power minus infinity. Okay, so this minus infinity stuff is always 0. So the output would be equal to e to the power minus e to the power minus x, right? So it is always e to the power minus x like that. Arkadaşlar, I hope you got the problem here. You find out the problem, because you know, here it should be, this should be not minus infinity, but it should be 0, right? Because my function is like this. My function is like this. How come I should take the integration from minus infinity, right? I shouldn't do it. I should start from 0 and then go to x, find the area under this curve, increase x, find the area under this curve. This is what this integration does, arkadaşlar. So this shouldn't be, again, this shouldn't be like that. This shouldn't be like that. This shouldn't be like that. Okay, what should I do? Again, minus e to the power minus u from 0 to x. and then the output is e to the power minus x minus e to the power 0. Well, this is minus 1. Minus 1 is 1. And the output is 1 minus e to the power x. Okay, so the area under the curve is always 1 minus e to the power k. So when x is 0, this is 1, and our probability cumulative distribution function, our CDF, will have such a graph like that. Okay, so I hope you got the main idea. Now we would like to find out the probability between 1 and 3. This is the final phase of this question. Probability of x being between 1 and 3. How should I think about this? I take my probability density function. I should think about this is 1, this is 3, and I'm interested in finding this area here, okay? So how do I find it? It's between 1 and 3. It is e to the power minus x dx. So it is like minus e to the power x. From 1 to 3, it is like e to the power minus 1 minus e to the power minus 3. And this is the probability, like 1 over e minus 1 over e cubed, okay? This is what the probability of any number between obtaining any number between 1 and 3. So I hope this was clear for all of you.